Algebra students, this is the video that I should have made for Tuesday and Wednesday night for Thursday, but didn't have time. Multiplying polynomials. So remember, polynomial just has many terms separated by addition and subtraction, and those terms are not like terms. So anything like x squared plus 3x minus 1, that's a polynomial. 2x, that's a monomial, but it's a type of polynomial. Negative 1/4 x plus 2, that is a binomial. And then something like x to the 5th minus 3x to the 3rd plus x minus 1, that's a polynomial. You've been dealing with how do you multiply two monomials together. That's when you use all those exponent rules. You've been dealing with how do you add and subtract polynomials. That's when you look for like terms. And what I'm talking about is how do you multiply polynomials together. You've done this before with a special case, something that looks like this. A times B plus C. That's called the distributive property. And you know you just take A times B, A times C, and you get AB plus AC. Well, the same thing happens with polynomials. If I give you 6x times x squared plus 3x, well, now you're just going to take 6x times x squared, and then you're going to add 6x times 3x. And what I would encourage you to think about is if I put some parentheses around these things, this is the problem that we were doing at the very first part of this unit. This is multiplying monomials together. Ignore what's over here in gold and focus over here. This says 6 times x times x times x. So this is 6x cubed. Or x to the 1 times x to the 2nd. You add those exponents. Over here, 6 times 3, and then x times x, and your answer is 18x squared. And the biggest mistake kids will make is then they'll say something like 24x to the 5th. No, you're done at this point because these aren't like terms. So that's all we're doing here. We're just multiplying polynomials. The distributive property is the easiest example. A tougher example is when we get something like this. 2x minus 3 times 4x plus 5. It looks really complicated, but it's not. I assure you it's the exact same idea. I'm just going to call this one number. I'm going to call it 2x minus 3. And I'm going to take 2x minus 3 times 4, and I'm going to take 2x minus 3 times 5. And when I write it that way, I get 2x minus 3 times 4x plus 2x minus 3 times 5. Now all I have is another distributive property problem. So I'm going to take this 4x and multiply by 2x and get 8x squared. I'm going to take this 4x multiply by negative 3 and get negative 12x. I'm then going to take this 5 multiply by 2x and get 10x. I'm then going to take this 5 multiply by this negative 3 and get negative 15. And now I'm going to look for like terms. 8x squared, there's no other x squared terms, so I'm done. Then I've got negative 12x, and I've got positive 10x. Oh, those are like terms. That's going to combine to give me negative 2x. And then last but not least, I've got negative 15, and that has no other like term, negative 15. And there's your final answer. Now, another way that many books do this problem is they take 2x minus 3 and 4x plus 5, and they say the way you multiply is you take the first products and multiply them together. You take the outside numbers and multiply them together. You take the inside numbers and multiply them together. And you take the last numbers and you multiply them together. And if I write out the first letter of those products, first, outside, inside, last, you see this word FOIL. Some mathematicians don't like calling this FOIL because it's really just the distributive property. It's not a process called foiling. But FOIL is a good acronym to remember how to do it. First, 2x times 4x, 8x squared. Outside, 2x times 5, 10x. Inside, negative 3 times 4x, negative 12x. And last, negative 3 times 5, negative 15. If you see the same four numbers from here over here, that's not a coincidence. That's because this method or this acronym is a way to do this process quickly and help you remember. First, outside, inside, last. And you get the exact same answer when you collect like terms. Another more difficult problem, the last one, is if you get something like 3x plus 4 times, and we'll make this real ugly, 3x cubed plus 1x squared minus 5x plus 2. The process that we did before, where we distributed this to everything, and then this gets multiplied to all those, is just a way. It's the mathematical process that's happening. But what you need to know here is you just need to take 3x and multiply everything in this parenthesis by 3x. That's how you're going to start. And if I do that, I'm going to line it up. 9x cubed, or sorry, let me fix that. 9x to the fourth. 3 times 3 is 9. X times x to the third is x to the fourth. Plus 3x to the third minus 15x squared plus 6x. Now I'm going to do the exact same thing with this positive 4. I'm going to take positive 4 and multiply everything in this other parenthesis by positive 4. 4 times 3x cubed is 12x cubed. Now look where I wrote that. I wrote it under the other 12x cubed because I know it's going to be an x cubed. Now I'm going to take 4 times negative 5 and I get negative 20x squared. Look how these like terms are matching up. 4 times, did I skip one? Oh, I did. Oh, you guys are watching closer than me. 4 times x squared, that gives me 4x squared. 4 times negative 5x gives me negative 20x, and 4 times 2 gives me positive 8. It is approximately 10:30 on Friday night as I'm making this video, so I am sorry for my mistake. Let me use a different color to fix that. 4x squared. Now I've got all my like terms matched up, and I just add them up. 9x to the fourth plus no x to the fourth. 3x cubed plus 12x cubed, 15x cubed. Negative 15x squared minus 4x squared, minus 19x squared. Positive 6x plus negative 20x, negative 14x plus positive 8. And now what I've done is I've multiplied these two polynomials together, and the way I did it, I had all the like terms match up nicely. Believe it or not, that's the only video you need for the weekend, but there is a second video, and it's actually the same one from an Algebra 2 unit that I showed earlier. So I'm going to share that Algebra 2 video with you, and all that is what happens when you have certain special forms. Have a good weekend. Watch both videos. Talk to you on Monday. Peace.